Thank you, guys. For those of you that do know me, just suck it up and listen for a bit. For those of you that don't, I'm actually a very friendly guy. My name is Zayd Kara. I'm a project manager and I work at Inesis. Now, for you, those of you that don't know who Inesis is, we're part of the BBD group, and we specialize in custom software development for the insurance industry. So, onto my very cheesy opening, which should be now. There we go. Welcome. So my talk today is going to be Docker for developers. It works on my machine. So one of the most insidious obstacles to continuous delivery and to continuous flow of software delivery especially is it works on my machine. Did I get a pose right? So anyone who's been part of a software development team or an infrastructure support team for that matter has experienced that phenomenon. And one of the most common places such teams would have experienced or you have heard this phrase spoken, anybody like to guess where? It's during an attempted demo. Right? The issue is so common that there's actually a badge for it. Now, I've got some badges here, look exactly like that. Perhaps some of you in this room have already earned the badge. I know I'd like to personally tattoo it onto some of my devs' foreheads, but that's a discussion for another day. I can proudly say I've not earned that badge. I may have used a phrase very similar with my clients. It works in our environment. There's a long-standing tradition amongst the agile teams, and it goes something like this. If I can remember. When someone violates the ancient engineering principle, don't do anything stupid on purpose. Example, breaks the build, they have to pay a penalty. Now that penalty can be either they have to contribute to a team's snack jar, or something even worse for an introverted technical type, like stand up in front of his teammates and sing a song. But it may not always be possible to avoid such problems in all situations. However, we can minimize the problem. We can minimize the problem by paying attention to few obvious things. Yes, I understand the word obvious needs to be used advisedly, but what contributes to it works on my machine phenomenon? I call them pitfalls. So there's typically 5 pitfalls I'd like to discuss. These pitfalls have solutions to them. And pitfall 1 and 2, I'd like to group them together because the solution to the problem is very similar. So pitfall 1, leftover configuration from previous work. Pitfall 2 is where your development and your test configurations differ from prod. Now, leftover configurations from previous work allows the code to run on the development environment, even on the test environment. But as soon as you deploy somewhere else, it fails. Many developers have set up their dev environment the way they like, either on their laptop, their desktop, or even in team shared development environments. As these environments grow project to project, as new libraries are added and new configuration settings are set, sometimes these configurations conflict with one another. And a team dev or a team or an individual will then do a manual configuration adjustment on that particular environment or whichever project is active at that particular point in time. And very quickly what you find is that your configuration for development becomes very different to what your configuration is for your targeted production environment. Okay? So what are the solutions to these problems? The one, don't reuse environments. That's pretty self-explanatory, and I think we do that quite a bit in our organization. The second one is isolated, dedicated development environments. I'm going to say it again. Isolated, dedicated development environments. Pitfall 3. Yeah, and this is something everybody can relate with. Unpleasant surprises when code is merged. Okay, so different teams and individuals handle check-in and check-out of code in various ways. So some would check out and modify code throughout the project. Possibly weeks and even months. Others would commit smaller changes on a more frequent basis. Now, most teams fall within this realm, and the best way to overcome this is solution to the problem. Sorry, the solution to the problem is smaller commits on a regular basis. Okay, smaller commits on a regular basis, and okay, just bear with me. Sorry. And try and quickly pick up on merge conflicts. You just speed up the process that way. Pitfall 4 is integration errors are typically picked up way down the line. So what happens is that even though the teams, they commit on a more frequent basis and they run the tests, as soon as it goes one step forward, all hell breaks loose. So what's the solution to that? Solution to that is simple. Static code analysis. Static code analysis checks your code for integration issues. The good part about it is that you run it before your code is compiled, and you can easily pick up any issues. The other one is to incorporate your integration tests as part of your continuous integration pipeline. So typically what you have is you have a build that runs, you have unit tests that run, and as soon as the unit test fails, the build fails. Try and implement similar. So you let your build run, let your unit test run. Immediately after your unit test, let your integration test run. As soon as your integration test build fails, you fail the build. So you'll start picking up these issues a lot quicker. This is something that I think we all go through, and that's pitfall 5. The deployments. Deployments are nightmarish all night. So we do deployments to UAT, 5 minutes, 10 minutes, done, dusted. Here we're going to do deployments to production. Start at 5 in the afternoon, 2 o'clock in the morning, you're still at the office. So, and that time is not budgeted for, it's not allocated for. So what does the team do? Team typically, they jump in, make the thing work, because very seldom do people actually want to do rollbacks. Okay, so they get the system up and running, but there's a cost to it, because you then have production issues, which then lead to further regression testing afterwards. So since I've highlighted some of the pitfalls related to the works on my machine phenomenon, Docker and containerization is the hype words of this year. So why would you use Docker over any other virtualization environment? So what I'm going to in this talk, I'm going to try and convince you, as well as Mr. Michael Scott, container and Docker fundamentals, what they are, installing the Docker engine, launching and experimenting with containers, and we're going to jump into some cool demos. So containers versus virtualization versus virtual machines. What are containers, why and what is Docker? We're going to look at the Docker platform, the overview of it, look at some terminology that you need to be familiar with, and then getting started with Docker, and then jump into the demos immediately. So who here has worked with virtualization sorts? Okay, so if you take a virtual machine, typically what you have is your server hardware, your laptop, or cloud-based environment. You then have your host operating system sitting on top of those environments. So it could be either Server 2012, Windows 2008, 2016, whatever. What you then do is you enable the hypervisor feature. What then happens is you then install the operating system. So you create a virtual machine, you install the operating system, you install the libraries, you install all its dependencies, and you've got your environments. What happens with containers, though? You've got the same infrastructure. You have the operating system that you install, and all you do is you install a Docker engine. Okay. What this Docker engine allows you to do, it uses the system kernel to do all its work for it. Okay. Then what you have is much smaller contained environments. So this is going to sound like a history lesson, but containers are a useful analogy. So cargo transport pre-1960, as you go through the way they loaded loaded the ships in those days, the way they loaded cars, and with the way they actually offloaded goods. So loading and offloading could take anything from few days to a month. So what happened then is you had a multiplicity of goods that needed to be sent throughout the world. You then had to be concerned about the interaction of the goods. So coffee beans and spices mixing together. You then had multiplicity of transport and storage mechanisms. Okay. Your concern there would be how quickly can you get it from a boat to a train to a truck. What that produced was, call it a matrix from hell. Okay. So what was the solution? The solution was to develop an intermodal shipping system, also known as shipping containers or ISO containers. So as we know, ISO is standardization. So standardized shipping containers designed and built for use across different modes of transport. So what you would have is that you could take that container, offload it from a ship, put it onto a truck or a train, store it in a warehouse without offloading and unloading the goods. What this also brought was cheaper freight costs, less damage and theft. And then eliminated that matrix from hell. So now your containers, because of the standardization, they could now be stored in almost any place, could be transported in almost in every way. So what this spawned was the intermodal shipping container system. So what we have today is we have 90% of all cargo is now shipped in shipping containers. Reduction in time to load and offload. We've got reduction in losses due to theft and damage. And we've got 5,000 ships transporting 200 million containers a year. So what's the relevance in terms of Docker? So what Docker does, Docker containers wraps a piece of software into a file system and allows it to be moved from place to place without any issue. So you're always running the same system in multiple places. What Docker then does, it allows you to run on multiplicity of stacks, so be it Linux or Windows. Your services and your apps interact appropriately. It then allows for the container to run on multiplicity of hardware. And then your concern about migration or smooth migration between the environments from UAT to, or from dev to UAT to prod makes it easier. Do we have any Star Wars fans in the room? Okay, so the best way to describe a Docker image is it's a blueprint, essentially what it is. Okay, it's just the base, it's got the operating system, nothing else running with it. However, a Docker image without a Docker container what the Docker container does, it builds on the Docker image. So you would then have IIS running, you would then have your database running, everything else on there. So basically, it has your dependencies. Now, what I wanted to tell you about this is that if the X-wing fighter, what's it without a Rogue Squadron pilot? What's it without its KX-9 laser cannons? And the other warheads, such as the concussion missiles. So why and what is Docker? So Docker has been, so containerization, containers has been around for a long time, but I'm going to focus specifically on the 2008 onwards. 2008 is where Linux containers came about, or it was the most complete implementation of Linux Container Manager. What then is Linux progressed, other players came into fold, and then Warden started doing their own, leveraging of what LXC does, but eventually writing their own. In 2013, Google came up with their open source offering for a sticker or a prize. Anybody know what LMCTFY stands for?
Let me containerize that for you.
I don't know what's in here, but And then in 2013 came Docker. So Docker is, I think it was around March 2013 that was released as open source. It also leveraged off LXC and eventually went on and wrote their own library container library, which is used now. So around October 2015, or June 2015, sorry, the Open Container Initiative was established under the auspices of the Linux Foundation. And Docker is currently in the process of donating the container format and runtime to this offering. And yeah, so there should be some interesting things coming out of this in the not too distant future. So what is Docker? Docker is an open source project that automates the deployment of applications inside containers. So think of a Docker, if you know virtualization, so think of Docker as an application virtualization. It's lightweight, it's open source, can be used by both developers and sysadmins, and brings you the ability to build, ship, run in any application on any platform. So let's call it the engine behind Docker is the layered file system. So typically what you would have is you would have the operating system. Oops, sorry, wrong button. Yeah. You have the operating system. You would then install the web server. You would then install the database engine. But all of these are layers within that image. At this point in time, everything is read-only. So we call those immutable because they cannot be changed. Once you install your app, the Docker container then has the ability to then read and write to it. Devops. So there's this hype around, just as with Docker, there's this hype around DevOps, and DevOps or Docker being an enabler for DevOps. So I think firstly you need to understand what DevOps is, and I think Donovan Brown has put it quite nicely there. It doesn't reference any tooling or any. It's a union of people, process and products to enable continuous delivery of value to our end users. So it doesn't talk about tooling whatsoever. So how is Docker DevOps enabler? So it's both a platform and a tool. So for developers, it would be a platform for building applications or running applications. And for the operation people, it would be a tool that integrates with their workflow. So Docker over time has gained quite a bit of popularity, as you can see. And it's starting to gain a lot of momentum as well. I mean, BBD is also starting to use it quite heavily. Getting started with Docker. So you have, there's two options you can get started with Docker, depending on what operating systems you're running. What you have is a Docker toolbox. Docker toolbox allows you to, it's primarily aimed at the Windows 7 and the older legacy operating systems. It installs Oracle VirtualBox for you. It installs the Docker engine for you, and it allows you to do whatever you can do within the Docker instance. The next option is where you can run Docker natively on Windows 10 and on Mac OS. Okay, but one of the later on I'll show you that there's prerequisites in terms of running Docker on Windows 10 at the moment. Okay, So let's look at some of the Docker terminology. What you have is a container OS image. So the container OS image is your first layer of your image, as you would like to call it, to your operating system. The container itself is once you've put your web server on it, once you've put your databases on it, that now becomes your container that you can now move between places. The Docker daemon engine, or the Docker daemon, or the engine does all the hard work in the process. Dockerfile allows you to build environments, and I'll show you in one of my demos, is where you pass it commands. So think of it as a makefile. You pass in commands, and it does everything for you seamlessly. So the registry is typically, think of it as a source control or repo where you can store your images. You then have the Docker Hub. The Docker Hub is it's a global repository where anyone can then go and pull images that are available and reuse them. Have a look. Let's just look at the Docker architecture. What you typically have is you have your client. You then have the Docker host. So what you can do is, if you follow the lines, you can build from a image and make it a container. Or you could layer a few images and make it a container as well. Okay. But typically what you would do is you'd pull from the registry, pull the image, create the host, all using the Docker CLI. So getting started with Docker. So this was what I mentioned earlier, is that some of the prerequisites to get Docker up and running on your laptop. Firstly, you need to have virtualization enabled. You need to have Windows 10 anniversary or creators update build version this or the greater. Okay, it won't run on any other build of Windows 10. You then need the hypervisor role to be enabled as part of the feature. And then you can install Docker for Windows. What's nice about this is that if you do not do the Hyper-V role enabling, Docker checks and does it for you. Okay. So let's go into the fun part. So earlier, because the images take a while to pull, I already pulled an image from the registry. Okay. So you can run a few commands. What I've run there is Docker images. So that's just telling me that these are the images that I have available on my machine at the moment. But if you wanted to search, you could search and those gives you all the images that you can pull from Docker at this very moment. Okay. But not only that, so you can actually, if you were looking for all the Debian images, you would find that as well. So you've got endless room to play with. All right. Let's just CLS. Okay. So what are we going to do now? Just bear with me. So what I've done here is I've set Docker run. So it runs a command in the new container. I've passed it to say it needs to run it interactive. So I'm now in that particular container, which container I've used for that particular image, and the command that needs to be passed in when it needed to run. So it's now opened the command prompt. So if you look here again, sorry, I'm jumping, but okay. So as part of this demo, what I'm going to do is I'm going to where's my I'm going to add a PowerShell. I'm going to add a PowerShell file there. Okay. Now I'm still in the container. I haven't exited out of the container. I'm now there. I'm there, as in I'm on my local machine now. So let me show you what. There's another command that you run that says Docker shows you all your containers. So there you can see there's my container I have. What they do is they use a GUID for the containers. You can change that. You can give it tags to change the names. So just bear with me while I take that and plonk it into there. Do it the other way around. Sorry. Okay, let's do it. Come on, you can do this. Yeah. Okay, let's just 685 BA 5 AAB 371. So all I'm saying is, Docker, please create me a image with the name Ines' Rocks. It's now created a image for me. If I go Docker, you can see now I've got the Nano server, which was my base. I've now got Ines' Rocks. Okay, so that's the layering that we speak about. You have your base image, and then you can put build onto it. So let me. What I'm doing now is I'm telling Docker to run my image or my container, and run for me the PowerShell script within the container. What the RN and the M flag does is basically it stops it and removes it. And ta-da! Cool. Let's carry on. Impressed? So that's one of the ways how you can create images. The other way I spoke about earlier is you can use Dockerfile. Now, what is Dockerfile? So I'm going to take you through a sample Dockerfile. Basically, what we're saying here is we're saying it always has to, the Dockerfile, the beginning line should always be from where, what do you want to pull? So the base image for building the new Docker image. The maintainer, which is always good, then you know who's written that particular Docker file. All that's now doing is it's invoking the DISM exe to install the IIS feature onto that particular image, and then creates an HTML file and publishes it out to say, hello world. The last command is basically specifies the command that needs to be run when the container is run. So you can pass it, if you want to say docker run the name, pass it a command, it then fires up within the container itself. Okay, so let's go on to demos again, and hopefully I can. Anybody here remember Nerd Dinner? It was a showcase from Microsoft, written by Scott Guthrie and Scott Hanselman. So what's been done is they've taken this ASP.NET app and containerized it. Okay, so we're going to go through the motion of doing that. Let's open this. And as I put so this is basically the make file that which we speak about, or the build file. Okay, you're saying that you're pulling through the Microsoft IIS image, who the person writing it is, and the commands that you pass to these, that you can pass within these images. What this command does, it's now installing SQL 2012 within that image for you. So there's just some things to bear in mind when you do this. Is they recommend not to fiddle with that particular line. I'm not sure why, but I didn't try fiddling with it, so don't touch it. What you're now doing is you're configuring the website, and you're exposing port 8081 on that. All you're doing is you're now removing the default website, creating directories within that container, and then giving the website a name. Okay, as well as you setting up your application pool for your .NET environment. So as you know, with IIS, you need to go and set up your app pools. This process does it for you. And the famous unlock config sections within IIS. That's all it's doing is saying that for certain sections of the web server handlers, we need to unlock to be able to write to them. Okay. So typically that's your make file. To take obviously what you need to do is get the code first, and then wherever the code resides, run the Docker file from there, from that location. What did I do? Did I just close it? Yeah, I didn't. Let's save. Okay, so that's typically taking a ASP.NET application. I'm not going to run it because the image itself creates an 8 gig image. So I'm not going to run it now. Okay, so there's plenty of references out there. Particularly like this infographic, it's Containers 101. So if you're new to it, grab it from my slides or just come to me and I'll share it with you. It's off the Microsoft site. And then there's some excellent reading material that you can look at. These two I recommend are the e-books that Microsoft have recently produced. And what's nice about them is that they have a whole application called, I think, the e-shipping container. And it talks about containers, it talks about microservices, because that's where we're going towards right now. So yeah, I suggest you, if you want them, I have the ebooks as well. Okay.